So let us discuss this theorem. So in this theorem, we have two scalar fields, f and g. And given thing is that del f and del g both exist at point A. What we have to prove? We have to prove that del f plus g also exists at A, and it can be calculated in this way. Del f plus g is equal to, at A obviously, del f of A plus del g of A. This thing we have to prove. Let us start with the given thing. Given thing is del f and del g exist at A. So you remember the definition of del f, that is divided by x1, divided by x2 and so on, divided by xn. Similarly, we can write for g. So del f exists. That means partial derivative of f with respect to each of its component exists, and same thing we can write for g also. So let us write that thing. So del f exists. That means deba f by deba xi of, so that this is exist, and this deba g by deba xi exist at A, and this is true for all I running from 1 to n. So all partial derivatives exist for f as well as g at point A. See, if two derivatives exist, we can add them, okay? And so in this way we can write, so therefore del f deba by deba xi plus deba g by deba xi exist at A, and again it is true for all I running from 1 to n. Can you tell me this is nothing but, this can be written as deba by deba xi f plus g, getting na? So you know well how to take partial derivatives. If addition is there, we can take separate derivatives. So same thing I have done here, okay? And this exists at A for all I running from 1 to n, okay? So this implies if all partial derivatives of f plus g exist, that means del f plus g is also exist at A. So this implies we can write del f plus g exist at A. So in this way we proved the first part, del f plus g exists at A. After that we have to prove this second part, del f plus g of A is equal to del f of A plus del g of A. We are going to prove it, make a screenshot of it, then we will go further. So now let us calculate del f plus g of A. So you remember the definition of del f, same definition I am going to follow to calculate it. Definition says that is deba by deba x1 f plus g of A, deba by deba x2 f plus g of A, comma, and so on. The last one will be deba by deba xn f plus g of A, okay? So this is equal to, so you know that in case of partial derivative we can take separate derivatives. So therefore this is nothing but deba f by deba x1 of A plus deba g by deba x1 of A. Same thing we can do for second component also. So I will write the last one, deba f by deba xn of A plus deba g by deba xn of A. Okay, so in each component you can see addition. So same thing we can write in this way. I will write all partial derivatives of f first, okay, deba f by deba xn of A plus, now I will write all partial derivatives of g, deba g by deba x1 of A and so on, deba g by deba xn of A. So you know that how to add two elements of Rn, component wise addition. First component plus first component, second component plus second component. That means again you will have a same step. Okay, can you tell me this is what? This is nothing but del f of A, and that second bracket is nothing but del g of A. So in this way we proved del f plus g of A is equal to del f of A plus del g of A. Okay, so see, make a screenshot of it and then we will go for one more theorem. So let us discuss this second theorem. What is the difference between previous theorem and this theorem? Here we have minus sign in between f and g. In last theorem we have seen there was a plus sign, but here we have a minus sign. So there is no much difference in proofs also between previous theorem and this theorem. See, what will we do? We will start with the given thing. Given thing is del f and del g exist at A. So therefore what can we write? Therefore deba f by deba xi and deba g by deba xi both exist at A belongs to S. Getting? So actually del f and del g we defined with the help of partial derivatives. So both exist. That means all partial derivatives of f and g exist at A. Okay, and this is true for all I. So I should write at the end. This is true for all I running from 1 to n. Okay, so see both term exist, so we can add. Okay, and that term also will exist. So therefore we can write this implies deba f by deba xi plus deba g by deba xi exist at, or simply we can write of A exist. Okay, and this is true for all I running from 1 to n. This implies the same thing we can write in this way also. Deba by deba xi of f plus g of A exists. Okay, and this is true for all I running from 1 to n. So same thing we can write it this way also. Getting? So f plus g you can operate separately. So again we will have deba by deba xi of A plus deba g by deba xi of A. So both of them have the same meaning. If all partial derivatives of f plus g exist, that means del f plus g is also exist at A. So therefore we can write del f plus g of A exist, or we can say it is exist at A. So in this way we proved, sorry, here is minus sign and we need to take minus sign since we have to prove minus here. Getting? So this is the only difference, remaining part is same. Getting? In previous video also we have done the same thing with plus sign. Here simply we need to write minus sign since we have to prove f minus g of A exists. Okay, so in this way we proved. So let us prove the second part, but before that make a screenshot of it. So let us prove this part now. I am considering del f minus g of A. Okay, so see, you know the definition of del f, so I am applying the same definition, deba by deba x1 of f minus g of A. Getting? And so on. We can find all partial derivatives in each component. So therefore finally we get deba by deba xn of f minus g of A. So you know that when we take partial derivative, we can take separate partial derivatives. So this is implies, or this is equal to deba by deba f by deba x1 of A minus deba g by deba x1 of A, and so on. And here at the end we'll get deba f by deba xn of A minus deba g by deba xn of A. Get it? So the same thing we can write in this way also. Okay, next line I'm going to write. So this is, I will write all partial derivatives of F first, and then we will write all partial derivatives of G. I hope all of you are getting what I'm doing here. Okay, so you know how to subtract one number of Rn from another number of Rn. Component wise subtraction, first component minus first component, second component minus second component. So again we will have the same thing, right? And this is nothing but del f of A, that is nothing but del g of A. So that means we proved the same thing. So in this way we completed this theorem. Thank you. Bye bye.